Hello, folks. Welcome to Rational Science. And I'm not going to give a lot of introduction today because it's going to be a busy day. So let me just get right to it. I'm going to be dealing first with a little bit of extinction and then go into the subject matter today, which is black hole, mass. What is mass? What is a black hole? Okay, let's get on with a couple of questions that I received. I want to answer those. They are related to extinction. Here's the first one. Fellow says, Bill, can you please post where you got that extinction graph of the Cretaceous terrestrial revolution showing the extinction of the ferns and the flowering plants, etc., taking over? I'm trying to find the reference. He couldn't find it. Okay, so here it is. Okay, this is where the paper appeared in 2008. Okay, that was the paper. I think that was the first paper that dealt with that issue. I cannot say for sure because the graph that I found originally was different than the one that Graham Lloyd there put out there. And this is, I guess, a presentation that he gave, a PowerPoint presentation. And that's number 9. You can see the graph is the number 9 on his presentation, and you see there the link, so you can find it there. Okay, and what I've done with that is essentially, modify it a little bit and clarify it. I don't take ownership of that information. I'm just going with what these people found out. As I understand it, it was a 4-year study where they showed that the flowering plants essentially displaced all other plants in the last, 50, 60 years of the Cretaceous. And if you look at that, what it's telling you is that the dinosaurs, which were feeding on conifers, primarily probably cycads or cycadioids, they were running out of forests and jungles. They had very little to eat, and their populations had expanded by that time. And so you have this crossover where you have more and more animals and fewer plants. And at some point, the extinction happens. Why? Because it's a mass extinction. What is a mass extinction? A mass extinction is the disappearance of a food chain. Mass extinctions only have to do with food. No asteroids, no diseases, no climate change, none of that nonsense. It's food. When food disappears, the animals disappear. That's how simple it is. Okay? Give me a second here. Oh, I'll get a little trouble. Okay. So again, it's got to do with that. The extinction theory we propose here is that all mass extinction, mass, not the background extinctions like Neanderthals, right? Mass extinctions only have to do with the disappearance of food. That's how humans are going to die. We're going to die when our food disappears. Why does it disappear? Well, because our economic system collapses and disappears. What do I mean by that? I mean that money itself disappears. At some point, we will have no interest in receiving money. We will have no faith in money. In God, we will not trust anymore. So the dollar will have to be changed to in God we don't trust, or something like that. Okay, another issue a fellow raised is, he says, I just ran across this problem when I read the study of 28,000-year-old Cro-Magnon man found in Italy. The study made it clear that this guy had no Neanderthal admixture. Okay, they found bones there, right? And they went to say it would be impossible to interbreed with Neanderthals. Yeah. And I railed completely against this admixture theory, which was a shock to me. I always thought European people had a little Neanderthal admixture. Guess not. And yeah, all I can tell you is this never happened. Okay? Neanderthal humping a girl, I doubt that very much. I don't think that ever happened. And I give you reasons. I have my arguments for why that never happened. Okay, here's one of them, just very quickly. Was she taken against her will, or did she come voluntarily, consensual? How does this work? Okay, please let me know. Okay, which one you think is the right one? Okay, so but here are my reasons. I have a series there for those who want to watch it. It's the Neanderthal series. This is just the heading of it, Neanderthal series. It's known as Against Admixture. And I have several videos, I think it's 15 of them, where I explain point by point why Neanderthals could never have mated with humans. It's like really like saying that monkeys mated with us. Never happened, never will. Okay? In fact, they tried a mixture of human with a chimpanzee, and it didn't work. And that's more or less what would have happened if Neanderthals mated with us. But here, let me show you just a summary of my arguments. Okay, you can watch the videos and they'll explain a lot more detail. Here I'm just going to give you kind of like the headlines of what issues I touched upon in the videos. And here's the first one. Against admixture, the Neanderthals and Cro-Magnons, they never met. Okay, in fact, I think that the only reason we entered like 35,000 years ago or thereabouts into Europe, into continental Europe, right, was because the Neanderthals were no longer around. Until then, any human group that would enter into Europe, he would be slaughtered by the Neanderthals. On the other hand, you see humans all the way going all the way to China. And you say, well, how come they went all the way to China? They didn't go into Europe. Well, it's very simple. There were no Neanderthals killing them from Africa all the way to Asia. On the other hand, there were Neanderthals killing them when they tried to enter Europe. And only when the Neanderthals were gone, that's when humans were able finally to enter Europe and find this cemetery of dead Neanderthals. There's no mtDNA, mitochondrial DNA. We have no Neanderthal mothers because that's what it would indicate. If we would have had the Neanderthal mtDNA, we would have had Neanderthal mothers. No Y chromosomes. That's passed on from father to son. So we have no Neanderthal fathers. So we have no Neanderthal mothers, no Neanderthal fathers. I think that does it pretty much. There's very little Neanderthal DNA in us, only 2 to 3%. That's all they found, and they probably stretched those numbers a little bit to make them fit. And yeah, that's very likely because we even have chimpanzee DNA for all that matter. The issue is we have very little, and that what that indicates is that we all descended from Homo erectus and some other intermediary that came, one from Africa and the other one from Europe. Neanderthal evolved in Europe, okay, completely in Europe. There was, you have in England, you have footprints and some, mammoth bones that were found, and they're dated to close to 800,000 years ago, the oldest one. The one is at Happisburg. And when you look at that, you're saying, okay, there was some kind of human-like creature living 800,000 years ago in England, merry old England. And you say, how can that possibly be? Yeah, and it's the Homo erectus who went there, okay? And Homo erectus, he did not have clothes. And it was very cold in Europe at the time, in fact, colder than it is today. There were glaciers extending all the way to northern England, Scotland, thereabouts. And so the question is, how did this guy survive over there? Well, the point here is that, these were woolly humans, the Homo erectus, and they got used to the cold. They went little by little, after thousands of years, they got used to the cold. From them descended the Heidelbergs or the antecessors, one of those groups. And from those, you have the Neanderthals. They all evolved in Europe. Neanderthals never knew what clothes were, and therefore they were with their feet, no sandals, no shoes, no boots. They were standing on the snow, just directly like a wolf would do, like a bear would do, like a mammoth would do. They needed no clothes. Okay, so they ran around nude, hunting, killing, whatever they did. That's how the Neanderthals survived. When we come from Africa, sunny old Africa, into Europe, we needed clothes. We invented clothes. And guess what? If we would have met a Neanderthal, nude, a gorilla there, he would have noticed a little difference between him and us, and vice versa. We would have seen this monster there, this gorilla, hairy ape, right? And we were dressed because we were cold. So we invented needles, we sewed, we put hides together, we covered ourselves. They didn't have to. Okay, so I doubt very much, even from the clothes point of view, that we would have made it. They would have recognized us as a different species. Okay, so there's part of the problem that we have from this theory that the Neanderthals were mated with us. There was that mixture, some mixing of the species, because we're not even talking about races really. And they did selective evidence. And here's my good old friend Svante Pabo, and he sweeps a lot of the stuff underneath the rug in his famous paper, in which he became famous in his group, right? And what did they do? Well, they mixed up a lot of stuff, and they didn't tell you the whole story when they go into the public arena. When they write their paper, they're very careful because they know they're going to be peer-reviewed, and some other people are going to complain about their findings and so on, or going to question their data. When you go to the public, you can say anything you want, and that's when they start lying, and they exaggerate their findings. Okay, and what are they exaggerating? Well, let me point out the main point, and that's they say non-Africans. They always talk about Africans and non-Africans, and that's a way of throwing the important details underneath the rug. Okay, they're sweeping that underneath the carpet, right? And what is it? The American Indians and Papua New Guineans, they have more Neanderthal blood or DNA, right, than Europeans, where the Neanderthals lived. And in other words, Cro-Magnons, right, or descendants, us. Here we are Europeans, right? I'm descended from Europeans for sure, right? And the Europeans have less Neanderthal DNA than Papua New Guineans and American Indians. And they put that in the report. But then they sweep it over by saying non-Africans. They lump everybody together with Africans and non-Africans. And that's cheating, that's lying, okay? They should make this is exculpatory evidence. Yeah. You got to leave that in there. You got to make people aware, hey, we got to explain this. Why do Papua New Guineans and American Indians, why do they have more Neanderthal DNA? And that got swept into history. You'll never hear about it again, okay? Another issue, Neanderthals never lived in the Levant, in the Middle East, in Israel and Iraq specifically. And they say we had mixed over there first. We had sex with the Neanderthals over there. Absolute nonsense, poppycock. And here's one of the reasons, Neanderthals were cold weather animals, okay? And they didn't ride camels. They didn't go to that far south. And the reason that you can tell that there's a problem, and again, people don't look at the details, and that's that if you look at the sites in Iraq and Israel where so-called Neanderthals were found, you will note that those Neanderthals or alleged Neanderthals were not the classical Neanderthals that you find in Europe. Okay, they're not the same. There's differences. And you got to look at the papers written by people from over there, from Israel, and from the archaeologists or paleontologists, and they tell you it's not the same guy that's in Spain, in France, in Germany. Okay, so those Neanderthals of the West, the classical Neanderthals, they do not match in many ways the skulls and other fragments found in the Levant. So that's, and again, you got to look at the videos, and I'll go into more detail. I put the papers there from where I got all that information, okay? So no, Neanderthals never went that far south. They were cold weather animals. We went north because we found prey up there, food, you know. Neanderthals weren't about to leave a place where they had abundant food to go south. For what? For what reason? To sunny Israel? It never happened. Okay? Anyways, then there's the issue of race versus species. Were Neanderthals of the same race or the same species as humans? You know, so we got to look at that. Are they different species? And for that, you have to define the terms. What is a species? What is race? Okay, and so again, you got to look at the video. There's an argument on that. We found no intermediate Neanderthals, half-breeds. They try to fit in the fellow kid there in there, but it's like force putting evidence to make their case. That's all it is. There is no transition between Neanderthals and humans. You find there's nothing in the record to indicate that at all, and we will never find it because there never was admixture. So, you know, it's very simple. Looks, clothes. I mean, if we came in there dressed up because it was cold and they were nude with their hairs covering their body like a gorilla, well, I don't know. I think both species would have seen each other as different. I don't think you're going to go into a cave and have sex with such a monster. Men with women, human men with Neanderthal women, and vice versa. It doesn't happen. And not in the wild, especially. In fact, in the wild, the worst thing you can do is have confidence. You know, you're quite naive. More than naive, you're dead if you trust. In the wild, you don't trust. Never trust. Okay, you treat everybody as an enemy, including those of your own species. You know, so keep that in mind. And there it is. Consensual sex, was it? No, I don't think so. I don't think female would have gone there and said, oh, I'm going to sleep with this Neanderthal, cheat on my husband or whatever. And one of the things is shouting distance. You know, one of the things that all animals learn, especially humans, when they travel in groups of clans or whatever they traveled as, and same for Neanderthals, by the way, when they travel, no one leaves the clan, the tribe, whatever you want to call it, the group. No one leaves it very far away because any animal can attack them. They should be within shouting distance. You should be able to shout and your group comes and helps you out. And especially if someone wants to have sex with you, you know, an ape wants to have sex with you. You say, my God, you know, you shout and everybody comes and helps you. So there is this thing where, you know, you find yourself in the middle of nowhere with some other species and you have sex in the middle of the woods. Okay, so please show me the movie of how this happened, okay? And yeah, it's got to be within shouting distance. And then some people say there's been trade. You know, they trade seashells. They found seashells in France. They said, well, those don't belong there. They must have come from somewhere else. They came from the Neanderthals, and then we traded, you know, collars, you know, made for a bear skin or whatever, or a mastodon skin, a mammoth skin, you know. No, there was no trade. Trade is something that begins with civilization. No other animal in the history of life on Earth ever had trade. Trade is something that people today think about. In those days, there was no trade. You had to hunt your own stuff, and if you were successful, you lived another day. So yeah, and here it gives you an idea of how they're trying to persuade you to believe that there was sex, and this is what they show you, and they show you, you know, this is the 1909, the first Neanderthal that they made a picture of, a drawing, and that's what he looked like, more or less. You can see how they've been changing over time. The Neanderthals have been becoming less hairy, whitish, you know, that we have to make them white, you know, because we can't have a black Neanderthal or a yellow Neanderthal. It's got to be a white man, right? He was in Europe after all, right? You can see how it's changed over time. Why? Because You ask any girl if she would sleep with a 1909 guy, and she probably would say no. She wants someone, viral, but not that much. And then you have this other one, the 2013. She might be willing to sleep with him. So you got to make it palatable to a woman to say, yeah, I would sleep with this guy, but not with this other guy. And that's part of the propaganda that they put out there to try to get you to believe that there was sex between the two species. Okay, and that's all I can tell you. Yeah, it's absolute nonsense that Neanderthals died because they were a smaller population that's kind of dissolved in the much larger human population. No, Neanderthals died because their population pyramid overturned. It's going to happen to all species, unless mass extinction comes earlier, which is in our case, we're going to die through a mass extinction, not because our population pyramid overturns, which is already overturned, by the way. Since 1963, our growth rate has gone down, and we're down to 1. It's going to go down to 0. We keep going like we are now. So we're not reproducing anymore. Why? Because we moved to the cities. When you move to the cities, you have no more children. The economy prevents it, the culture prevents it. There's many constraints, and so people don't have children. Can't have 10 children in an apartment. And so, we're having fewer kids, and that's what happened to the Neanderthals. They started having fewer kids, one, and then the other one is that their DNA, their genetics, their genetic pool was whittling away. They were becoming more and more clones of each other until they finally expired. Okay, so let's move on to some of the questions people asked since last time. And here we have this fellow, he's at the volley, says, good info, Einstein did not believe both theories, meaning quantum mechanics and general relativity. Was there a video about this? Yeah, I put this up there several times, and here let me show you again one more time. Einstein did not believe in quantum mechanics at all in his entire life, and he stopped believing in general relativity. He became an atheist in general relativity. And here it is. This is how he ended his days at Princeton. And he says, I've become an obstinate heretic in the eyes of my colleagues. Okay? I am generally regarded as sort of petrified object, rendered blind and deaf by the years. He kind of became old, and they left him there, and they didn't worry about him. Okay, and so they kind of turned him into a poster boy, for general relativity against his will, because he no longer believed in this nonsense. Here you see it. All these 50 years of conscious brooding have brought me no closer to the answer of the question, what are light quanta? Nowadays, every Tom, Dick, and Harry thinks he knows it, but he is mistaken. I consider it quite possible that physics cannot be based on the field concept. Okay? Field theory, that's what his equation is. It's a field equation. So he stopped believing in it, and he says, on continuous structures. Okay? In that case, nothing remains of my entire castle in the air, gravitation theory included, and of the rest of modern physics. He wrote this as late as 1954. He died, I think, 1955. So he stopped believing. He became an atheist in his own religion, the one he created. And to punish him, relativists essentially, turned him into the poster boy of their religion. Today, everybody has to mention Einstein. Oh, Einstein. If you say Einstein, your paper gets published. It turns out that, Einstein is rolling in his grave. He doesn't like that. He said, look, I don't believe in my own theory anymore. I realize that it's nonsense. But people continue to put him up there as, as the Einstein is a synonym of intelligence, Okay. Another fellow, he has something else. He says, truth and belief aren't synonymous. Okay, real physicists gave up long ago looking for stuff in matter. Yeah, in other words, he's right. You have Richard Feynman says, they've given up on all that stuff. So they don't do that. In fact, they never did. They always did equations. They always did numbers and variables. They never did objects. They never explained. They never gave a physical interpretation using objects as mediators. They always used concept, field, energy. Time, you bend time, waves, all these concepts, they reified them, turned them into objects. And then they started moving the concepts around, these reified concepts. There's only fractal energy, whatever energy is, right? Space is the connector, container of the subatomic particles. Space is nothing, so it can't contain anything. You need something with shape to contain. And so you can't. And it's not a connector because it's nothing. How do you connect A with B if space is not a physical thing to connect them? Connect implies object, a thing. Okay? And there's enough love. I think you said energy, but it's the same thing. It's a concept, right? So there's enough love in a teacup of space to boil all the world's oceans. Yeah, these people talk nonsense. Why? Because they're using the words of mathematical physics, which is all these concepts, and they're treating them as objects. So they use the word energy, the word field, the word wave. These words are forbidden in science, in physics. Okay, you can use them in math, but keep them in math. Don't bring them ever into science, okay? Because they mislead. Their only purpose is to mislead. Okay, so here we have another fellow, and he says, along the same line, says, but you don't have an objective basis for your knowledge. Therefore, my belief is true because I claim objectivity. And he says, average metaphysical philosopher, I guess he signed his title there or something. Okay, so we have to find out, what does objective mean? Well, objective in physics is what comes out of the screen, out of the event. That's objective. Once it happened, once it's history, only Mother Nature, God, the devil, Father Universe, one of those guys knows what happened exactly. It's in a file cabinet out there in the universe somewhere, right? But for us humans, we have no actual, access to that file cabinet. We can only speculate on what happened. Okay, and so we cannot really know for sure what happened. We do not know the truth, if we're going to call truth what actually happened. No one can know that, okay? And you might say, well, I know, I just saw him kill this person right in front of me. I saw it with my eyes. You're the only person on earth who knows it, but now you're going to have to tell someone else. And the other person has to believe you. Believe your knowledge. Okay, that's the way it works. And so, no, we don't deal with knowledge in science. We don't deal with knowledge in physics. Knowledge is what? Justified true belief. It's a belief. Knowledge means that you know for sure, but your neighbor doesn't know for sure or believes you're lying. So you know the truth, you know for a fact, but for him it's a lie. It's a falsehood or whatever. So we have no use for knowledge, and there's no such thing as that. Objective is only what Mother Nature already put in her basket, in her file cabinet. Okay, we have no access to that information. We can only make assumptions, speculate, etc. Okay, believe. And the way we do in science, we make an assumption. Let us assume that this is what happened. Let us assume that this is the case. Let us assume God exists. That's how we started science. We don't say, I believe in the existence of God, or I don't believe in the existence of God. That's irrational. Those are irrational statements. No, in science we say, let us assume God exists. We make an assumption. Then we explain based on that assumption. Okay, so here another fellow says, the core of a neutron star is probably some phase transition between hadron gas and gluon plasma. We have no use for hadron or gluon or plasma. Those are forbidden words in science. Okay, we don't use those foul four-letter words. Okay, there's no such thing as a gluon. There's no such thing as a hadron or plasma. Those are not things. Okay, the first two don't exist because they're particles, and you can't explain anything with particles in quantum or in science or in anywhere. We don't have particles, discrete particles. Okay, so again, neutron star, it could be made of neutrons. We have no problem with that part of it, but we have to know what a neutron is, what it looks like, etc. We have to illustrate the neutron in order to talk about it intelligently. And so no, I can't agree with what this fellow says there. I don't even know if he knows what he said. Okay, another fellow says, he says something about the speed of light. He says 300 million meters per second in a vacuum is only true when measured from one inertial frame of reference. But from another frame of reference, which has relative speed differential to the first frame, the measured speed of light must be c plus or minus v, the velocity of the object, right? Plus or minus the velocity of the object. In other words, if you have a flashlight on a train, right, the train is going, 100 miles per hour, you have to add that speed to the speed of light on your flashlight, or if you're from another point of view, well, you would have to subtract it. That's what he's saying. So c is not a universal constant, only a local constant relative to the measurement system. E is frame 1. In frame 1 is a different measured value to c in frame 2, if those frames have relative motion. Do you agree? No. No, in science we do not measure. Okay, that's the problem. Okay, we do not measure. It's the mathematicians who do measurement and a lot of nonsense out there, and then they reach the most irrational conclusion they can find. So the way we do it in science is this way. We say, look, c equals frequency times wavelength, okay, under light. And if you raise the frequency, you lower the wavelength, and vice versa. Okay, so what happens? You can get a rope and you can count the number of links, okay, for a meter or whatever length of rope. And you count the number of links. Now you torque the rope more and more and more, you're going to have more links, and each link will be shorter. And vice versa. If you untorque it, you will see that there are fewer links and each link is longer. And that's what the equation says. That's why c is always a constant. It had better be a constant. Not because we measured it, we don't care about measurement or what the observer observed. We don't care about any of that. We look and say we have to conceptualize what light is. And if light is a rope, the speed of light had better be a constant. Okay, that's the way we do it. Okay, so c equals frequency times wavelength is the equation of a rope. That the rope is the only thing that can simulate that equation, which is a constant. Okay, 300,000 or close to 300,000 kilometers per second. Okay, and final question. Fellow says something about infinity, and he says yes, infinitely small is not a measure, quantum amount, and comes in conflict with the concept of a Planck length. Okay, infinity is a process, not a quantum, and he's totally right. Infinity means that mathematicians are going around in circles forever, or figure eights, sorry. So infinity just means that you're chasing your tail around. That's all it is. It means that you're running around forever. There's no object, it's not a noun. Okay, infinity is a verb. Infinity means you're running forever, counting forever, whatever, doing forever, eternally. And so there is no such thing as infinity. It's a concept that is totally alien to science and to physics. It only has validity in mathematics, where they count forever and they say, hey, the numbers extend until you get tired of counting or whatever, or you die, whichever one comes first. Okay, let's get on with move on to the subject of today. We're going to talk a little bit about the mass of a black hole. What is mass? What is a black hole? Well, let's begin here. Let's begin by finding out what gravity is, because black hole is related 150% to gravity. So we need to know mass and gravity. So we need to know what gravity is, what mass is, what are these things? And so let's start with a couple definitions first so you can follow along. Okay, let me go with these. Force. What is force? These are out of dictionaries and Wikipedia and so on. An influence that can cause an object to change its velocity, in other words, to accelerate, meaning a change in speed or direction. Okay? What is pull? What's the kind of force, right? There's push and pull. Those are the only two forces that we can imagine. You either push something or you pull on it. Then you can change the direction and or the velocity and or the acceleration. Okay? So to draw or haul toward oneself or itself. Okay? So pull is towards you. or towards the object. Okay, it's an attraction. It's a tug. Okay, let's get that right. So we know what pull means. A lot of people want to do pull through push. They want to push from the outside, right? Okay, and then you have mass. What is mass? It's a measure of the quantity of matter in a body. Okay, and there you see a little caveat there from the Wikipedia. It says mass in modern physics has multiple definitions, which are conceptually distinct. Yeah, here we are, 400 years after Newton started talking about mass, and they still haven't figured out what mass is. You will now find one definition. They have all these other definitions, and they introduce some throughout the presentation, throughout the dissertation. Whenever they need this definition, they use that one. Whenever they need the other one, they use the other one. Okay, and so this is the problem. The mass is a massive problem because they never defined the word mass. Even to this day, they don't have a definition, a scientific definition, one that we can always use consistently. Okay, they have all these 500 definitions, and they use them all at the same time, and that's a no-no in science. Field. What is a field? You need to know what a field is. Very important word in mathematical physics. A physical quantity. I like that. A physical quantity. No such monster. Either it's physical, meaning it's an object, a thing, or it's a quantity, which is a concept. So it's either an object or a concept. What did they do? They merged them together to cover all the bases. They said it's both. It's an object and it's a concept. You know, God is both an object and a concept. God is this human figure, and he's also love and intelligence, who knows what else. Okay, so they put them together and they say, hey, we got our God. He covers all the bases because he's an object, he's a thing, and he's also a concept. And that's a no-no in science as well. So a field is not a physical quantity. It's just a quantity, nothing physical about a field, that has a value for each point in space and time. Okay, so it's numbers. Field is a bunch of numbers. Okay, let's get that straight. That's how we're going to use it here. Okay, so if you say, oh, but the field moved, then no, fields don't move because numbers don't move. Okay, you got to understand the definition of the word field. You need to know what a force is and what mass is. And there you have it. Okay, so now we can move on. Here we have an expert. Her name is Jana Levin, and she's a mathematical physicist. She's not a physicist at all. She's just a mathematician and thinks she knows something about physics. And here she'll tell you what gravity is. Pay attention to what gravity is. Here it goes, okay? Listen, there it goes.
Gravity wants to attract us to the Earth, and the Earth to us. But the Earth is so much bigger that even though we're actually pulling the Earth a little bit to us, you don't notice it so much. You know, the moon pulls on the Earth a little bit. The moon is such a big body compared to anything else very nearby that it has the larger effect pulling the water of the Earth. But more than the moon, think about the sun pulling on the Earth. We orbit the whole sun just the way the Earth pulls on the moon and causes the moon to orbit us. All of those things are acting on you and me right now.
Okay, so what is gravity according to Ms. Levin? Well, it's pull. Some kind of pull, whatever pull is, okay? We had a definition just now, so that's what it is. And here we have another fellow who also says that it's some kind of pull. Okay, here it is. And he's Derek Muller, and listen carefully.
If you have your
Sorry, it's Richard Muller.
It's a big mass here, and you have you with your little mass here, that every atom on the Earth is pulling on every atom of you. You're also pulling on it. And then there's a lot of atoms here you're pulling on. You're pulling on all of them. The amazing thing about gravity is it goes right through things.
Okay, so we have Richard Muller. He's from Berkeley University. I think he's retired now. I'm not sure about that. And Jana Levin, they both say that gravity is some kind of pull. Every atom on Earth, let's get that right, every atom on Earth is pulling on every atom of you. So let's just pull one atom out of you, one atom of the Earth. What they're saying is every atom here in the earth is pulling on every atom of you. One atom is pulling on you, on one atom of you. One atom against one atom. One is pulling. How do you pull without a mediator? That's what you have to think about. And just in case, let's rub it in one more time. Here it is. These are different statements out there, from prominent places. Obviously, you have to have a prominent place. People believe in authority and, how many mathematicians voted for a definition or whatever. Well, here it is. Here's from Jefferson Labs, their nuclear facility. Gravity affects atoms the same way it affects all other matter. Every atom creates its own gravitational field, which attracts all other matter in the universe. In other words, every atom attracts every other atom. Next one. Gravity is a force that pulls all objects in the universe towards each other. So if you have an atom, it pulls another atom towards itself. Every single object with mass exerts gravitational attraction on every other particle in the universe. Atoms have mass. So you have an atom that's pulling on another atom. Again, pull, attraction, okay, tug. Every single atom pulls every other atom, stack exchange. It is true that each atom attracts every other atom, okay, and ask an expert site there. Gravity, an invisible force that pulls objects towards each other, NASA. Okay, so how do you pull? Well, you can have a tape there, like I put up on the top there, the white one. You can have a rod. You can have a chain, the one in the center. You can have the one right above it, which is a thread. Okay, you have a rope underneath the chain. You can have a ruler or some kind of tape of some kind. You can have wire, you can have a cable, coaxial, whatever. It's got to be an elongated object that pulls between any two atoms. Okay, it's got to pull. One atom has to be able to pull on another atom. The only way you're going to do this is having a mediator, a physical mediator. Okay, I don't know what part people don't understand about that, but that's what is required in order to produce gravity. You need to have pull, and that pull has to have a mediator. There's no other possible way that we can imagine. If you don't put a mediator there, you're doing black magic. You're doing action at a distance. You're doing, witchcraft. You're saying this object pulls on that object, but there's no mediator between them. Okay, so that's the situation. You had better put something between two atoms. Okay, it's got to be a mediator. It's got to be a physical mediator. It's got to be an object, a thing, and an object is that which has shape. Okay, you don't have to see or touch it, but it had better have shape because that's the definition of object. Okay, so here's one of the ways these people try to explain the movement of the earth around the sun. The sun pulls on the earth pulls on the sun, and so they have this mechanism which has nothing at all to do with pull. Here it is. Okay, you see the earth rolling around the sun, and it's going what? It's going through this depression. They say, hey, the earth simply cannot leave the depression. It's kind of trapped in this hole. Okay, that's the way they do it. And instead, what we have is a little different proposal. We're saying, no, the earth goes around the sun because every atom on earth is bound to every atom of the sun, like they just explained. That's how you can explain pull. And then you have this centrifugal motion of the earth, and that's what keeps it in its orbit. The fact that it's tied, but at the same time, bound, to the sun, every atom of the earth to every atom of the sun, and at the same time it's rolling around, and so it has no other choice but to stay within the solar system. And here you have a very crude notion of how the earth goes around the sun, more or less like this. Okay, a boy swinging a ball at the end of a string or a rock or whatever. That's why we do not fly out of the solar system. Very simple. Every atom on Earth bound to every atom of the sun. Very easy to understand. The only problem, we can't see or touch the mediator, because an object is not that which you can see or touch. An object is that which has shape. And that's where the problem was all these years. Okay, so what do we propose? Here it is, very simple. We say that every atom is bound to every other atom. Here you have the 2D on the left, the 3D version on the right. Okay, and what you have is this rope, pair of bound threads. We call it a rope because that's what it looks like. That's the only reason we call it a rope. And you can see the atoms are pumping. They're going back and forth doing their quantum jump. And by doing so, they torque the rope. And the torsion along the rope is what we call light. And that's essentially the model. This is the construction of that model. Okay, you can see the one thread goes through the center of the atom, builds what we call the proton star, and then the other one goes around and forms the electron shell, which encapsulates the proton star. That's the model. Okay, that's the thing. Okay, and every atom in the universe is bound to our atom. Okay, that's essentially the model. Okay. And so here's the underlying hypothesis to that, which is there's a single thread in all of space. Okay, that's all there is, and that thread turns into every atom and to every rope that connects any two atoms. Okay, so that's all there is ultimately. If we were to untie every atom in the universe, dissolve it, somehow disentangle it, right? That's what we would find. We would find a closed loop thread. What's the object? A single thread. That's all there is. And what's the black stuff? That's space. And space is that which doesn't have shape. In other words, that's the definition of nothing. Okay, so don't look for a frame around the black stuff because there ain't one. Okay, it's just nothing. It has no shape. That's what space is, nothing. And the only thing is this thread which turns into matter and the energy, you could say, the rope that interconnects any two atoms. And here's the transition. You have the single closed loop thread, and if we were to untie everything, right? And here we're going in reverse. We're going to tie that. We're going to bind it, turn it into these threads that tie every atom in the universe, and there you have the model at the bottom. That's what it looks like if you were to take any two atoms. That's our basic model. That's our starting point. Okay, so what are we saying? Are we saying that there was an evolution from single closed loop thread to matter and the ropes that interconnect them and vice versa? No. I think at least all I can tell you what my opinion on this is, okay? And that is that the universe has always been like it's been right now. There's always been stars and galaxies and planets and atoms bound together by ropes, and that's never going to change. Never going to change. All you have is explosions of stars that throw some of the gases and other matter outside, form other solar systems, and the process is eternal. Eternal in both directions. We never had a beginning because you cannot imagine how space, nothing, spontaneously turns into something with or without God, because he would have to explain the process, how he turned something into nothing or nothing into something. And so it's impossible even to conceptualize. Even poor God cannot conceptualize that. Okay? So no, matter has always been there. It's always been there as atoms forming bigger structures such as asteroids, planets, moons, stars, and eventually galaxies and so on. Okay, so that's our starting point. Okay, now we need to find out. So we realize that gravity is some sort of pull. It's an attractive force. It's on the inside, and people say, "Well, how can you be sure it's pull?" Okay. Well, let me give you a very good experiment. You like experiments? Do this experiment. Always in the presence of a trained relativist. Okay, this is a very expensive experiment. It costs about $1 billion. So you're going to have to look around to see if someone is willing to finance you, etc., to do this experiment. You can do it sitting down or standing up. Always in the presence of a trained relativist. It's very dangerous. Okay, you put your arms like that, stretched out, either standing up or sitting down. It doesn't really matter. I'm going to do it sitting down. And you stay there for about an hour. And what you will find that there's nothing pushing your arm downwards. It's a pull from below that's getting your arm tired. That's going to make your arm go down. Okay, so there's no birds, dodo bird sitting on your arm pushing it down. You're going to realize that it's coming from below, the tug. Okay, so all you have to do is stretch your arm for a little while, and you'll see how it's being pulled from below and not pushed from above. That's to get a feel for the pull of gravity. Okay, so yeah, gravity is a pull, and we've always known this. We always had the intuition of it, and people started creating some of these Lesage or Casimir type processes where they remove the matter between two objects, and they say the particles or whatever from the outside are pushing them together. So they have this push gravity. People with very little mental capacity, actually, it fails miserably. Okay, so here we go back with our good old Jana Lemon, and she's going to tell you how you do action at a distance without a mediator, okay? And how's she going to do that? Well, like all mathematicians, they're going to invoke this ether, right? And they don't call it ether anymore because, Laughlin or Nobel Prize said it's taboo to use the word ether. So what they say, they call it space-time, or they call it field. And I'm going to do it with a field. What's field? A bunch of numbers, right? Value at each point in space. That's what a field is. Remember, that was the definition we had. Okay, so here we go. This is Jana. And listen to her carefully. Here it goes.
So you can also think of a gravitational field, something that permeates all of space. Even though the Earth is 3 stories below us, it's not as though it's pulling at us from a distance. We're actually interacting with the field at this point. And that's nice because people were worried that if things acted at a distance, that the way the old-fashioned inverse square force law describes it, that it was as spooky as like mind-bending, that it was like telekinesis. If you don't touch something, how do you affect it? And so the first step was to start to think of gravity as a field that permeates all of space. And it's weaker, very far from the Earth, stronger, very close to the Earth. So one way to think of this field is as a field that's really describing a curved space-time that is everywhere.
So how do you do gravity according to the mathematicians? Well, you put in this field because somehow you have to touch it, right? Because if you don't touch it, how do you affect it? She's right. That was the key question. And so the way they figured it out, they said, we're going to touch it with these numbers, these values. In other words, what they're doing is describing. They're not giving you a physical interpretation. What they're doing is describing that, we have these numbers, and they get weaker the farther away the object is from this one. So the gravitational field and gravitational force or mass or whatever is weaker the farther it is away. Okay, the tug is weaker. And so all they're telling you is a description. So what do they have? They have in their minds that there's this field that permeates all of space, whatever field is. It was a bunch of numbers, but they're turning it into an object and saying, we're going to touch that other object. The sun is going to touch the moon through the field. So now they've converted these bunch of numbers into a canvas, into a physical object, and they're going to touch it indirectly. In other words, they're not going to tie a mediator between the Earth and the sun. What they're going to do is they're going to stretch this platform on which both celestial objects are sitting, and they're going to say, hey, the sun can affect the Earth and vice versa through this platform. Okay? And what they're going to do, they're going to do it through push, not through pull. That's the issue. And here we have another fellow, and his name is Derek Muller, the guy I confused you with earlier. Says, talking about Newton, he says, he concluded that every object with mass must attract every other. Yeah, but Newton was troubled by his own theory. How could masses separated by such vast distances apply a force on each other? And this is what he wrote. A famous statement from Newton says that one body may act upon another at a distance through a vacuum without the mediation of anything else is to me so great an absurdity that I believe no man who has a competent faculty of thinking could ever fall into it. Absolutely. He couldn't figure out how it worked. And he wanted to do it with particles because he was a particle man, just like everybody in his generation. They were all etherists. They saw this universe as a bunch of particles in the background that was creating all these phenomena they couldn't see or touch. And so they created the ether, a bunch of particles, and even with that, they could not explain it. And so they said, I have no idea how this works. I can only describe mathematically using mass, and he didn't use the word field, it didn't exist at the time, but he could do it with mass and talk about gravity, gravitational attraction, but he did not understand how the process worked. And so they had to create this field thingy. Okay? They had to get this field thingy, and here we have good old Derek, also like Jana, telling us that it's the field. Okay, so listen carefully to him. Here it goes.
Bodies do not exert forces on each other directly. Instead, a mass like the sun curves the spacetime in its immediate vicinity. This then curves the spacetime around it, and so on all the way to the Earth. So the Earth orbits the sun because the spacetime Earth is passing through is curved. Masses are affected by the local curvature of spacetime, so no action at a distance is required.
So the solution to action at a distance was to create the field, the platform on which the celestial objects are sitting. They're looking at this as a two-dimensional stage. Okay, and so they have these two objects sitting on this platform. They bend it, and it's the stage itself that's going to create the action at a distance, meaning there is no action at a distance because you now have a connection between these two objects, which is the stage itself. Okay? So whatever the stage does affects the objects. That's the notion that they came up with after centuries of dealing with gravity. Okay, what's the problem with that? Well, let's start slowly so that you can see step by step what the problems are, okay, with their version. Here we have the Earth and the Sun, okay? And the Sun is, you can see, weighing down this so-called space-time thingy, okay? And let's go with the first problem. The first problem is that that's not a space-time thingy, okay? It's not a thingy. What is it? Well, what it is number lines. What you're looking at are number lines. They're not dimensions. They're not coordinates. They're not vectors, like physical ones. What they are is number lines. And they take these number lines and they treat them as physical objects. They put them all together and say, hey, we have a stage now. We have a canvas. We have a fishnet. Okay, so they turn the number lines into a thing. That's where the first problem is. Okay, and so they're suggesting to you that this is what's happening. That you have this warped wall of time that's bending and it's preventing the Earth from flying out of the solar system. Okay, which is already quite ridiculous because they're saying that time is warped, and that's why the Earth. That's what prevents the Earth, physically prevents the Earth from flying out of the solar system. So that's the first irrationality in this whole sequence. What's the second irrationality? Probably more important also. Here it is. And that's that you need push because the sun has to push the canvas downwards. Why does it push it downwards? Why not upwards in this two-dimensional vision? Well, because they have to show you why the Earth is going around a depression, right? Like a little ball rolling around a hole, a bowl or whatever. So they have to put the bowl, but in order to create the bowl, they have to have the sun push the canvas downwards. Canvas? No, it's not a canvas. What was it? Number lines. So they're pushing the number lines downward, bending the number lines in order to create the depression around which the Earth is going to rotate. Okay? And it turns out that, okay, so we have push, and they just told us that gravity is pull, so where does pull come in? Well, it doesn't come in at all because it turns out the Earth also is going to be pushed downwards. I mean, what is pulling on the Earth towards the sun? Even if you bend that canvas, assuming it's a canvas, why would it go downwards unless you got Newton's force? And again, this is the problem. These people are using Newton's force to explain gravity, which Einstein said it's a no-no. He said it's a field theory, okay, a field equation. And so we have a contradiction from mathematical physics, because on the one hand they have the sun pushing downwards, the earth pushing downwards, both using Newton's force in order to explain the field concept that Einstein embodied in his equations. Okay, so there is a contradiction there that they'll never resolve because they don't have physical interpretations that you can even sink your teeth into. It's just worthless nonsense coming out of mathematical physics. Okay, so where are we at now? Okay, here we have the difference between Newton and Heine. Okay, Heine says his equations say that gravity is not a force, as in Newton's equation. Field is alleged to be a continuous structure that fills the entire universe, space-time. And Newton's forces are mediated by particles that comprise the ether. Heine's field is simply another word the mathematicians invented for the ether. Okay, and there you have again the definition of the word field: a value at each point in space. So they're turning this value into a physical entity. Okay, and that's what they're going to be bending, the field, and how do they bend it? Using Newton's force. So we have a contradiction there, because the field equations of Einstein are founded, in order for you to explain his mechanism, they're founded upon the concept of force that Newton had. Force equals mass times acceleration, or force equals, in the case of gravitational acceleration, you have gravitational constant g, mass divided by distance squared. Okay, so again, they're using force to explain the field notions that Einstein introduced in 1915. Okay, so what's the result today? How much do these people know about gravity? Well, here it is. We'll get a philosopher of science, as they call him, whatever a philosopher is. They never define philosophy, but here it is. This fellow, Alan Chapman, he's from Great Britain. He says, in the Principia, Newton had given no explanation for what gravity was, only how it worked. Correct, and that's exactly what Einstein did. He just told us how it worked, not what it was. To the followers of Descartes in Europe, such as Gottfried Leibniz, the introduction of gravitational forces working at a distance seemed like a disguised version of medieval thinking. It seemed to many scientists that what Newton was doing was bringing black magic. Absolutely. Newton didn't know what gravitation was. He admitted it. He didn't know what gravity was. We don't know what gravity is today. Did I read that right? We don't know what gravity is today. Okay, so we have these people, here's 10,000 years later, and they don't know what gravity is after all their math, after all their experiments, all their equations, and they still don't know what gravity is. They can't tell you how gravity works. And you have the contradiction where the field is a continuous structure, assuming we concede it, right? As a physical entity, no problem. But then they say, we do it through push. Hold it, you just told me that gravity is a pull, and now they're going to explain it, with all these equations, all these visualization, they explain it through push. They say the sun weighs, pushes the canvas downwards, and the earth slides downwards because it's pushed, really, not pulled, because what's pulling on it? It's being pulled, or you could say it's pulled, but by what? There's no physical entity. So we don't know why the earth is falling towards the bottom of the depression. Is something pushing it? Why is it rolling downwards? Because of gravity? Because of force? Because of Newton's equation? So this is where the contradiction comes in. Okay, so here's one fellow, and he questions this, and he says the following. He says, wow, lots of baseless and pointless rhetoric. You really have no understanding of science. I'm so sorry. Physics requires math because of the scientific method. Okay, let's see what his scientific method looks like. He says, observation, quantitative and validated. Rigorous math model that explains all the relevant observations. Those models must be capable of making predictions that the other competing theories can't. And then those predictions must be seen. Okay, so proof, evidence, verification, right? And that is the case with black holes. It was the point of the data collection. Yeah, they did a lot of data collection. They said they came up with this nonsense called the black hole. Okay, so what's the problem with this gentleman? Well, he knows very little about science, okay? Here we have it. Observation, that means gawking. You gawk, because by observing doesn't mean you understood anything, you know? And gawking is not science. There he says that math explains. No, he never learned this. Math has no power to explain whatsoever. Math can only describe. It's a descriptive language, not even science. It's not even part of physics. It's just a language. And this language does not have the ability to explain. There you have one of the emeritus professors who says, science doesn't explain, science describes. Meaning math doesn't explain, math describes, because they've equated. It's the mathematicians who have turned math into science, math into physics. Okay, it's them. Why? Because they cannot explain with math. That's why they said, hey, science doesn't explain. Yeah, of course, because math doesn't explain. Doesn't mean science doesn't explain or that physics doesn't explain. Okay, that's what the problem is. And then predictions, that's astrology. We don't do that in science. Reading, palm reading and all that kind of stuff. You're in the wrong field, buddy. We don't do predictions. Okay, so I don't know where you studied, maybe in a monastery, but yeah, we don't use math. We don't do experiments in science. We do not observe. We do not gawk. We do not do predictions. We only explain. If you can't explain, you're not a scientist, let alone a physicist. Okay, that's the way it is. Okay, and here we have it, just in case. I showed this a couple of weeks ago, I think. And so this fellow Beecham, he will tell you what physics is about, what people want to know, what people want to understand, what people ask when they talk about physics. What questions do people ask? Here it is.
You're not currently floating around the room. Why are you not floating? Because of gravity, of course. So the ultimate question underneath it all is, what causes gravity? So physics, as you know, this is the type of question, what causes gravity? This is the type of question that keeps physicists up at night. Because physics is, among other things, as you know, the search for mechanisms. Physics is, among other things, as you know, the search for mechanism. Physics is, among other things, as you know, the search for mechanism. The reasons or explanations for why certain things happen the way they do, the why and the how. And if a physicist comes to you and says, and asks you, what causes X phenomenon, and you tell her, that's just the way it is, she'll be very dissatisfied with your answer.
So what is physics about? Physics is about mechanisms. You need to have a mechanism. You don't have a mechanism, you're not doing physics. Mechanisms require objects, not math. We don't need equations. We do not need words such as field or mass or energy to explain a mechanism. In fact, you can't use those words because those are reified concepts. So you cannot use those words in science, okay? What can we conclude? Well, here's a kind of like a summary, okay? Math can only describe. Math has no power, authority, or mandate to explain. Math only deals with what? Dynamic concepts. That's all that math can do. It doesn't have any power outside of that. Math never dealt with static concepts. Even geometry, it's all itineraries. It's all perimeters, okay? 1 plus 1 equals 2 doesn't explain anything. E equals mc squared doesn't explain anything. And you can put any equation you want in there and it will not explain. It will not give you a physical interpretation. It will not tell you the cause. It will not tell you the mechanism. On the other hand, physics only explains. Science is rational explanations. Math phys only has irrational explanations, meaning math phys is totally irrational. Math is only reification, the movement of concepts. And there you have some examples: transfer of energy, move the mass, wave the wave, shake the field, bend time, warp space, carry a force. That's how mathematicians talk. Their entire language is irrational. It's amusing. It's laughable. It's ridiculous. Okay, so how do we get to the black hole with all this? I mean, now that we've covered gravity and know that it's a pull force, how does a black hole pull? They say it's got a lot of mass. Okay, let's concede. Let's give all the mass they want. I don't care. Infinite mass, we'll give it to them. How does it pull? How does this mass do its work? That's what we want to understand. Okay, the mechanism. Show us the objects, how it pulls. And again, we said pull, you need an elongated object. And they're going to try to do it in a roundabout way by using the so-called field. And in order to do that, they had to convert space around the black hole into a field, meaning into ether, meaning into something physical that they can bend or whatever. Okay, so that's how they're going to do it. And this starts here with space.com. They had an article that says the Nancy Grace Roman Space Telescope will hunt for tiny black holes that date back to the Big Bang. And what do they show? They show many black holes, and this is what they look like. They have all these black holes going right through space. Space is nothing, so you have a hole, which is nothing, so you have a hole into nothing. Great, it's absolutely adorable. Love it, So what can I tell you? This is the state of science today, according to the mathematicians. So they have all these little black holes. They have different sizes of black holes. Some holes are big, some holes are small. Okay, and it turns out that we shouldn't have a hole at all, because black hole is absolutely nothing. It's the definition of nothing. And someone's put a comment there, and he said the following. Says, your title is an assumption based on entirely on a theory. There's no real requirement that black hole objects have zero volume, zero mass, zero time, etc. Well, I don't know what he means by requirement. I don't know why he used that term. Again, these people don't even know how to ask questions. The word requirement doesn't fit in there. It's so incongruous in this situation. I don't know what he means by requirement. A black hole has to be zero dimensional. It has to be zero size, zero volume, zero mass, zero matter, zero everything, no shape, etc. And so let's make sure you understand. Hopefully, don't believe in me. Nobody believes in me. I want you to look at the experts, the people who are experts in black hole. Here's the first one. There's Stephen Hawking, okay? He'll tell you right now what it is. Talks about Chandrasekhar, and Chandrasekhar was this Indian fellow who started working for Arthur Eddington, and he started doing some calculations on using Einstein's field equation, and he applied it to stars and said, hey, a star that's much bigger than the sun turns into a black hole. What is a black hole? Well, here you'll see it. Says this is out of Hawking's book, A Brief History of Time. Eddington was shocked by the implication, and he refused to believe Chandrasekhar's result. Eddington thought it was simply not possible. Okay, listen to this. That a star could collapse to a point. Okay, Einstein himself wrote a paper in which he claimed that stars would, not shrink to zero size. Zero size. We're not talking about little. We're not talking about infinitesimally small. We're saying zero. You know what zero is? Zero is different than infinitesimal. Infinitesimal means that you still have something in there, something that is very small or getting smaller. This is not the case. We're saying it's zero size. You know what zero size means? Nothing. That's what a black hole is. It shrinks to zero size. And what happened? Well, they gave Chandrasekhar, as you can see later on there, they gave him the Nobel Prize in 1983 for proving mathematically that a black hole bigger than the sun collapses to zero size, crushing all matter out of existence. What is mass? Mass is the quantity of matter. There is no matter, so there is no mass. So we have a zero size, no shape, no volume, nothingness that has no mass. That sounds like the definition of nothing. Okay? And here you have, just in case, proof, evidence. Another guy says, on solving the equation with a particular value rho of central density, you will get a model of a star with mass m and radius r. Plot r as a function of m and show that r falls to what? To zero. R meaning radius falls to zero. What is zero radius? Means nothing. Means no volume. Means absolutely nothing. Okay, we have no length, no width, no height. We have no dimensions. We have nothing when m is equal to the Chandrasekhar mass. Okay, that's what he won the Nobel Prize for. Chandrasekhar did. Okay, so all I can tell you is, the black hole. All black holes fall to zero size because not only do they crush all matter out of existence, but they collapse to a point, to a singularity, which is absolutely nothing. So we have no mass because there's no matter, and mass is the quantity of matter or a measure of a quantity of matter. That's why we had to define these words up front. Okay, and so we have good old Jana living again, and what does she say? She's got the wrong idea. She says, the interesting thing about black holes is that they're hugely heavy, but they're actually physically really small. So this lady, she did not learn the first thing at all at the monastery or the convent where she studied. She didn't realize that, no, they're not really small. They're absolutely nothing. They're zero size. Zero is not small. Okay, so a black hole is not, or singularity, right, is not small. It's zero. Zero volume, zero size, no shape. Okay, that's the first thing. And they can't be hugely heavy because black holes crush all matter out of existence, and therefore there is no matter, meaning that there is no mass because mass is a measure of the quantity of matter. That's how simple it is, okay? But let's see how good old Jana here contradicts herself, because she's going to say something even weirder, okay? What did she just say? It's small, okay? Let's find out how small it is. Let Jana tell you in her own words. Let me get this. Where did he get it? She'll tell you in her own words. Here it is, okay? Pay attention. Here goes.
A black hole might be different than you imagine. It's a place and not a thing. The core of the star keeps collapsing, and where it goes, nobody knows. The black hole isn't anymore a crush of matter. It left it behind in its wake, but the stuff of the star is gone.
Okay, so it's not a thing. Black hole is a place. So how big is a place? It's a location. Okay, it's what they call position in math. Okay, so a black hole is just a place. It's a location. Okay, that's what she's saying. And people don't understand that. They're not listening to what she's saying. In fact, she's not listening to herself. On the one hand, she says it's very small and very heavy, and then she says, oh, by the way, it's not a thing, it's a place. So how heavy is a place? What's the size of a place? A location. And here we have another bozo, okay, and his name is Derek Miller. He says, in theory, you would see everything that has ever fallen into a black hole frozen on its horizon, including the star that formed it. He's saying that things don't get crushed out of existence. They're there, but you simply cannot see them from the outside. So he's saying that they're all kind of stuck in time between the event horizon and the singularity. They never really got crushed out of existence. It's just that the person on the outside can't see them. So he said, but in practice, photons are emitted at discrete intervals, so there will be at last a last photon emitted outside the horizon, and therefore these images will fade after some time. He's talking about the observers on the outside. He's saying that these objects don't really disappear into the singularity, don't get crushed out of existence. The table is still there, the rock is still there. It's emitting light, but the guy on the outside cannot see it beyond the event horizon. This is just one of the strange results that comes out of the general theory of relativity, our current best theory of gravity. This is the best theory of gravity, right? The first solution of Einstein's equation predicted not only black holes, but also their opposite, the white holes. I mean, they invent all this garbage, white holes, black holes, whatever, blue holes. It also implied the existence of parallel universes. Oh, great. And even possibly a way to travel between them. Well, I hope not. This is a video He's talking about his video about the real science of black holes, white holes, and wormholes. So this is the real stuff, people, okay? So please pay attention. And then he tries to tell you what a black hole is. He says it would require a lot of mass. He takes this big mass, the star, bigger than the sun, right? And he's going to collapse it down to a tiny space. That's how he's going to explain this, this transformation from a star to a black hole, okay? And so he talks about a tiny space, okay? So he says big thing turns into little thing, okay? And then somehow the matter still remains somewhere between the event horizon and singularity, or maybe on the surface of the event horizon, who knows, because they just keep telling different stories different times, okay, depending on how they want to make their money that day, okay? And then he says the following. He says, a lot of mass collapses down to a tiny space. Okay, great. The singularity is not actually a place in space. Instead, it's a moment in time. Okay, so let's see if we can reconcile some of these versions. Here we have good old Jana versus Derek, okay? Jana says, a black hole is not a thing, it's a place. And Derek says, a black hole is not a place, it's a moment in time. And all these people are PhDs. They're teaching out there, and they're making money convincing the public that they know something about physics and about black holes. Let's look at the conclusions. What can you say about a black hole? Well, here it is. Let me put it very clearly to you. A black hole is not a thing. It's a nothing. It's a nothing. Black hole is invisible, can't be touched. It has no size. It has no shape. It's 0D, meaning no length or width or height. Has no volume. It has no matter because it crushed it all out of existence. And it has, therefore, no mass because mass is the measure of the quantity of matter. What is a black hole? Nothing. If they're all 0D, if they're all no volume, no shape, and they have no mass, all black holes have the same exact mass, 0. That's the mass of any black hole. So when they talk about all these black holes, one bigger than the other one, and this one's humongous, all they're talking about is a number that they put in an equation, okay? And they put it in there what? So they can explain in their roundabout way why the visible matter acts the way it does. So if they see a bunch of gases moving around or a star moving around, they say that was caused by a black hole. Where's the black hole? Well, we can't see it, but it's a mass that's in there. And that mass supposedly is 0-dimensional, has no matter, therefore it has no mass. Therefore, you're saying, okay, so what do we have? And even if we concede all that, how does that mass affect the star or the gas, the real one, the one they can see? Well, they say that mass weighs down, Newtonian-like force, weighs down the canvas, and that one affects the gases and the stars millions of miles away. That's their explanation. They call that a field. They say it's warp time, whatever they call it. And that's the state of the art of mathematical physics in a nutshell for you. We'll see you next week. Bye-bye.